Bonjour à toutes et à tous, bienvenue à cette quatrième séance de lundi numérique, la dernière de cette année 2022. Et nous sommes heureux aujourd'hui d'avoir avec nous Marco Caglieri, chercheur senior au Conseil national de la recherche italienne, qui nous présentera aujourd'hui 3D Hope, la présentation web interactive pour les patrimoines culturels en 3D. Je vous rappelle que la présentation se déroulera en anglais et donc avant de passer à la langue anglaise, juste un rappel car l'intervention durera 1 heure et ensuite il y aura une demi-heure pour permettre au public en ligne de poser des questions. Je vous rappelle que vous pouvez poser les questions sur Zoom, sur le bouton QR. Je passe donc tout de suite à l'anglais. So, welcome everyone. We are glad to have with us Marco Caglieri, senior researcher from the Visual Computing Lab of the Italian National Research Council. Today, Marco will present 3D Hope, an interactive web presentations for cultural heritage in 3D. Just a reminder for everyone, the presentation will last 1 hour, and then there will be a half hour for the public to ask questions. So I leave the stage to Marco. Thank you.
So hello everyone. The presentation is already okay. So first of all, thanks for having me here. Thank you for the inviting, and it was a pleasure to come and present our work. A few words who I am. I'm Marco Caglieri. I am a computer scientist, so I have a master's degree and PhD in computer science, but I mostly work on cultural heritage in the digitization and lately more on the use of 3D model of cultural heritage, especially online. And I'm senior researcher at the Visual Computing Lab, which is a small group. We are about 20 people, and we work on different flavor of 3D graphics. We are part of the Institute of Science and Technologies of Information, ISTI, which is part of the Italian National Research Council, CNR. We are located in Pisa, just outside of the city, very large building. It's a maze to get around. So we work on different aspects of 3D graphics. There's a part of the group that works on cultural heritage, so as I said, digitization, but mostly also the use of 3D technologies for the management, study, restoration, and communication to the public of cultural heritage. There's another part of the group that works on real-time graphics, so especially about showing a massive data set. This is part also of the thing that we show today. And there's another part of the group that works mostly on geometry processing, so all the algorithms that are used to manage, display, and lately also make them physical again, so going from the computer to physical objects. So we go full circle on that thing. There's a recent trend also on artificial intelligence, so we use deep learning to do things on various fields, but also in this case, cultural heritage is one of the focus, so mapping of orthomosaics and recognizing artifacts is part of what we do with artificial intelligence. So as most of the group is made of computer scientists, we write software. And sometimes it's an effort that is just for one project, just for one event, just for one specific use. In some other case, we try to create and support for the community different software, different tool, and we spend some time on this part of our work because it's always a good way to keep the project alive, to reach out with the community, and to find new projects and find new activities. So we are developing and distributing MeshLab, which is a pretty well-established software for the visualization and editing of 3D models. We worked a lot on RTI, so reflectance transformance imaging, relatable image is the most used name, and we are writing again all the software for the processing visualization. There's a new tool using artificial intelligence, that's called Tag Lab, and then there's 3D Op, which is the topic of the today presentation. So, a couple of steps before 3D Op. As we did a lot of scanning, we had a lot of a very nice 3D model, and we wanted to show them or to make possible a close inspection of the object. So actually, through the years, we had many iterations of visualization software for a high-resolution model. Most of the time were local software, standalone software, very dedicated tool, and required some installation and a lot of work to set up a new inspector or presenter, as it was called at the time, for different objects. And another of the ingredients is the fact that since we are a computer science group and we worked a lot on visualizing massive data set, we have a pretty strong experience with multi-resolution. So those kind of engine that makes possible to visualize in real time very large data set by doing, well, most of these engines do exactly the same thing. So they get the original geometry and then divide it in chunk and then simplify the chunk and then divide it again. So in the end, you don't have one single object, but you have a lot of chunks at different resolution. And depending on how much memory you have, how much powerful is your computer, how much bandwidth you have to when you transfer this data, you try to render the best possible version of the object according to your budget. This started as a C++ library and then ported to JavaScript. And unsurprisingly, this working scheme works very well online because you can stream data, so you have an effective use of the network and a progressive encoding. So you get something to see as soon as the page opens, and then the more you work or more closer you get to a certain area, you get more detail, especially where you need it. And this works very well when you have very large model. And then the last ingredient is the web platform. Why going towards the web? Well, everything is going towards the web. You normally use bank through the web. You do shopping through the web. So people is using that platform. So it makes sense to offer another option, which is working on this kind of geometry, on this kind of data. It's easy to reach out to the public because no one ever wants to download another software just for a specific tool, but they all connect to the browser to see stuff from different projects or different things that they are interested. Then there's a lie. They tell you that when you work on the web, you have more uniform access across platform. You have to work a lot to have uniform access across platform, but yeah, it's doable. And then you can have the interface and graphics used everything that is already inside HTML and CSS. So it's easier to set up the graphical part of your presentation. And the faster development cycle is true. So it makes sense to go in that direction, especially when you have to, every project is slightly different from the previous one, so you have to do a lot of customization. So here is 3D Op. 3D Op, 3D Heritage Online Presenter, is a tool for creating visualization of high-resolution 3D. More precisely, it's a JavaScript library that contains some components that can be configured and assembled in a viewer based on HTML5 and WebGL that can display on the web high-resolution geometry. Has been designed for a cultural heritage application in the sense that we used all the past experience by working with cultural heritage to try to find which were the basic building blocks and components and ingredients and the things that you needed to configure for working in this field. It's been released in 2014, so it's becoming old. It's open source, GPL3, and distributed on GitHub. Just to show you that this thing exists and can do what I said. So this is a basic 3D viewer that shows a high-resolution 3D model. This is, if I'm not mistaken, 30 million triangle with 8K texture. It's an excavation in Voltaire about the amphitheater that they recently discovered. And it's possible to see pretty in detail all the excavation area. And you see that when I move around, new data is fetched from the network. But there was something to see as soon as I opened the page, which is essential when you work online. You want to give direct feedback to the people. And here there are some of the basic tools, like you can just see the geometry. It's possible to take measurement, and it's possible to do cut through sections. So these are some of the tools available in 3D. So what are the key points of 3D? First of all, it can deal with a very large 3D model, which especially when you do diagnostic work or scientific work on cultural heritage, you need to use high resolution geometry. Works natively inside almost all browser and platforms, so no plugin, and you can directly use your GPU, so it works very well also on all the machine and all the people that work in the field. It's fully client-side, so you don't need to set up a special server for it, you just need some space. And since it's possible to do your own publication, and you may do it also on a local network or inside your institution, you keep control, you maintain the full control on your own data, which for many applications is a plus. The interface is configurable, the graphics and everything about the scene and how you navigate and interact with it is configurable, so it's possible to build pretty diverse application, and I hope to be able to show it some to you today. And it's easy to connect the viewer with the rest of the web page, so you can build full page app or more complex interaction between 3D and non-3D elements. Then finally, it's an open source software that is developed by researchers for the research community. And that is also a point that is interesting in many situations. As computer scientists, we hate documentation. We hate writing documentation and we hate reading documentation. But in this case, we really strive to work and prepare information for the user. So the website has pretty complete documentation with example, how to, and it's possible to learn to use the tool just by following everything that's on the website. And we believe that this helped the process of adoption. I still hate documentation as it. 3D is a fairly wide user community, cultural heritage, but not only, and has been used in many feature projects and used daily in our activities. I put here some numbers. They're not really important, but just to show that from the beginning, the trend is a rising trend, and it jumped up when the pandemic struck. So one of the side effects of the pandemic was to promote that kind of shared online work that we were working on it since a long time. So it's not a success on itself. It's a demonstration that the work, that placing the data online and having people work in a shared online environment could have been a good idea since the beginning. So when I say used by the community, it means that there are actually a lot of people using it. All the example in this page come from something that has been developed by other people. And you see that there's cultural heritage here, but there's also other fields like medicine, ecological monitoring, or geographical services that use 3D, because in the end, many people need to build a specific viewer for their data and being able to connect it to other part of the page. Like this, for example, was very nice because they connected a CT scan to the cross-section of the skull, so that they could connect different kind of data in a single page viewer. And then there's people with a lot of fantasy. This is a thing that just popped out this month, and it's an advent calendar done in 3D. You can go and pick open these boxes until the current day, so you can get a surprise every day, a 3D virtual surprise. You don't actually get 3D model, unfortunately, but you get it in this very nice advent calendar. It was just to show that it's possible to use the software in many different ways, something that you don't even imagine, like this one. So we started using 3D for very, very basic stuff. So interactive display of high resolution 3D object. That's it. I want just to be able to load the model and show it online. Since it's possible to configure the interface and it's possible to include the viewer in the web page and connect to the other part, and also because it's possible to configure the viewer directly from a script, it's easy to integrate the viewer inside the CMS or the web database. So most of the use, and I will say that also most of our users use 3D in this way. So it's a single page, single object visualization tool, or it is a repository catalog viewer for 3D data. But one of the things that we did most with 3D is build interactive kiosk for the museum. So since it's possible to configure the interaction, it's possible to build things that are especially for a data set or for a specific museum. And the web-based technology offers other opportunities. So you develop once and you can deploy the result on both the museum kiosk and online, which save a lot of time and effort. And the graphical setup and that use all the 3D data from all the graphics from HTML makes easier to connect with the other part of the kiosk. Here are 3 examples of interactive kiosks that have been developed. One of the main things is you need to build an interface that can be used by the general public, and normally through a touch interface, so you have to change a bit how things work in order to obtain something that can be used on a touch screen. In this case is the interactive kiosk that we created for the Alchemy by Jackson Pollock. So we participated in the work of the restoration. So we did a pretty high resolution 3D model of the painting, and this was used during the restoration to plan the restoration activities. And then we started doing this interactive kiosk for the final exhibition. So you see the interface completely changed, and it's something that can be used with a single finger. So you have some of the usual features here, but then you can change the lighting. You always have the minimap that helps you navigate, especially when you're very close, and it helps people in not getting lost inside the object. And then there are the usual hotspots that show some detail of the painting with a text comment that describe what you are seeing here. And it shows mostly the object without color because of how the exhibition was. So the exhibition was like a decomposition of the painting. So it presented the painter, the age, the technique, the material. So we also did a decomposition of the object. So we showed the geometry and then the color in a 2 separate way. See that by combining the basic element of the viewer, you can also achieve higher level of communication and presentation. Then we thought, okay, this is good for outreach, but how to support people working on the data? So we tried to build other kind of viewer that had access to the high resolution geometry that was helpful for study and for briefing. Briefing, like in the restoration of Alchemy, people use the 3D model to plan the intervention before going on the actual painting. So in this sense, briefing, inspection and measurement, and rapid development of interaction was other things that we wanted to achieve. And we discovered what we discovered. We saw that one thing came out very interesting. So the possibility of using the same data for both the technical use and the public outreach. And again, since this is again a consideration that you do for economy, because creating a 3D model is costly and it takes resources and time. But if you're able to use the same data both for the technical work and for the public outreach, you have done something more effective in terms of access. So in this example, we show it because it's really fun. It was the conservation of the Ecce by Antonello da Messina. So we have a pretty high resolution model of the painting, but the problem with this painting is that it's been carved out by a wood-boring insect. So actually behind the painted surface, there's a lot of galleries made by eaten by the wood-boring insects. And so it's possible to combine the data that comes from 3D scanning with the data that comes from a CT scan. And you show this geometry using transparency or using cut-through section. So you get an interactive map of the risk of the current status, but also if I need to clean this area, can I touch it without fear of going through it? And yeah, of course, no one will try to clean it with. So, but in any case, this gives you a pretty good view of the state of the conservation, and is a technical interface because you see that you can be very precise in locating, in taking measurement, in assessing the data in a more scientific way that is different from what we have shown in terms of the public. But we still use the same data set also for the public. So from the same 3D model, we built a simplified version of the viewer that had predefined view modality that showed a specific aspect and put it in an interactive kiosk. So the next logical step was, okay, it's very nice to use the viewer to see the data in a scientific way. But what if I'm able to create data inside the app? And a very good example is this project, is the restoration of the Neptune fountain in Bologna. And it was done by the ISTR, the Central Institute for Restoration in Italy. And they wanted to have a way to do the documentation of the restoration in a completely 3D way. So we built this application, which is half a web database and half a 3D exploration system. And everything that has been done in terms of analysis, but also in terms of cleaning test and mapping of the degradation has been ported in 3D. And everything is done inside this platform. So actually, when the new data is entered, you enter all the metadata about your analysis or cleaning or technical mapping, but inside the application, you can also draw the polygons or lines or points and create the mapping, and everything is connected and can be browsed in this mixed way. So you can explore through the classic queries of a database, but also in a visual way by exploring the hierarchy and the types of the different elements of the statue, and then you can go and pick different parts of the object. So this was a very good example of the Web 2.0. So you can create data from within the web and use it back inside the web through the application, because this thing was done during the restoration from within the scaffolding, because this is covered by the Wi-Fi of Bologna. So the restorer were working and they were inserting new data that was instantly available to the guy that was working just next to you or in another part of the stadium. Another example of this idea of creating information inside the system is the dynamic collection. It's a project done in collaboration with the Lund University. And here the thing is about providing a series of objects that are part of the collection of the museum and of the university, and let you build your own collection. So you can, from the different objects available, if you need to teach a class or you need to do a research as a student or as a scholar, you build your own subset, you build your own collection, and you can annotate this collection, and you can take a look at each object individually, and you can then again comment and annotate and enrich each of these objects. So you build your own annotated 3D collection, and then you're able to share it with colleagues or your professor or your student, and this want to promote this shared shared approach to work on the data. Another project also done in collaboration with Lund University was the archaeological interactive report. So everyone that does excavation at the end of each year normally has to produce a report that describes everything that happened, everything that has been found. So we tried to see if it was possible. And normally when they do the excavation nowadays, they always do 3D models every day or every 3 days or every layer they uncover. So the 3D data is already present in some documentation, but what is missing is something that lets you create a narrative over it. So the system itself, if we go and take a look, it shows the different year of the excavation, and for each of the year, it shows the different trench, and for each trench, you can explore the 3D model, and you can explore the report, which is a narrative. So it's the archaeologist that is describing what's happened in the trench. So you see some text and you see some of the elements, and what you will normally find in a paper report is that there's some text and then there's a picture showing what the text describes. And here in this case, you have the text, you have all the data that has been linked to that part of the text, but you also have full control over the 3D data, and you can explore in a three-dimensional way, you can take measurement, you can slice the object, and you can access all the 3D elements that are part of this scene and explore it. So you can read the narrative as it is, so following what is described by the archaeologist, or you can go and be free to explore as you want the entire content of the three-dimensional representation of this thing. And all the authoring of the system was done inside another web page. So here, what I showed you was the output, but the input and the authoring parts where the archaeologist load the model, assign the different meaning, create the different sub-scene, pick the points and where to place the findings, draws the different layers and areas. Everything is done inside the web application. So it's another of those cases where you create data and the data is available for further study and further use. And this thing was the prototype, the first version, and now in collaboration with INSHA, we are moving to a more complex system that is based on MKS. So you have everything that I showed, plus a more complex semantic mapping of all the elements, and a more integrated interface that let you combine and access all the data in a much more structured way. So it's still an ongoing work, like it's always the case. Similar thing, but was way less complex, well, more similar to the dynamic collection is a work done in collaboration with CNRS and Humanum about the restoration of Notre Dame. We worked on a very small case, which is just the visualization of the ribstone of one of the vault arch. So that they recovered the stone, they did the scanning, and they wanted the system to be able to explore in detail these different elements, measure using various tools, visualize in different way, measure in different way, and we try to build these using the same component that we are using for the dynamic collection, plus some other components that we have developed especially for this project. This is the other thing that always happens. So web development is slightly easier than C++ development. No, not easier, faster. So it's easier to build things and move them from one project to another, and this is the case. So both the dynamic collection and the restoration of Notre Dame project added something to the tool that we have about 3DOP, and we integrated different tools in one project, and then we ported to the other, and so on. So it makes some of the development, especially this kind of hectic development. So every time you change a project, you have new data, new way to explore, new data. And I would say that it's easier to follow these things using web development instead of classic C++ stuff. So now I finished with the example, and I will speak more about the management of the project and some aspect about how this work. So first of all, we will complain a bit. Complain because yes, it was a success. We have a lot of people using it, and we are happy to find every day someone new that use the project and use it for very interesting stuff. But mostly we have basic user. So most of the user of 3DOP, as I said, is about very simple viewer of single object, which is perfectly fine. I mean, I'm not getting any money if you put more models inside your viewer. But it seems that the community is not able to unlock the full potential of the software, which is probably partly our fault. So we did something wrong in designing it, and we need at one point to correct it. And this is kind of standard situation. So when you work with the community, even we have a lot of experience with the community, and we have a lot of contact, and most of these projects have been developed with people from the cultural heritage world. So we got a lot of feedback, but still, the process of designing a software to be used by a completely different audience from what you are is not an easy task. And to make it harder, especially in the web world, but also all over the development world, find the sweet spot in which level you are working in is difficult. So you can think of high-level stuff, ready-to-use viewer, where you just you have zero configuration, you have zero customization. You just put your model in and you have the viewer ready, which gives you instant result, but not the possibility of adapting the viewer to your specific need. Or you can go on the complete opposite side. You can go low level. So you start from a development library. There's many out there. You have full control, but every time you have to build everything from scratch. It gives you complete control of everything, but you have to do it from scratch every time. So in between, there's an entire world. And the entire world is complex. So it's complex to find where you want to position yourself. So 3DOP was never meant to be a silver bullet able to do whatever about 3D visualization. So we saw that there was a middle ground available, and the middle ground was something that was an almost ready-to-use viewer, but still containing few components that you can configure to build a more complex application. This approach is fun, and it has a lot of advantage because depending on how much you want to invest on it, you can cover a lot of this intermediate space. But in the end, if you look at it from another point of view, it falls short on both ends. So when you just need to visualize a single object and you have zero need for customization, it still takes more time to go through 3DOP than using some of the other viewer around. And when you're trying to build an extremely advanced stuff, so if you want your interaction to be very complex, then things become very difficult. So in the Neptune, I cheated a bit because in the Neptune project, we also had to write a lot of additional code at a very low level inside 3DOP to make it work. While everything else that I showed you is done by just using 3DOP and then writing JavaScript code, but at the page level and not at the core of the application. So sometimes you have to get your hand dirty, and we know that that kind of code, it will be difficult for people that are not coming from a computer science background. And one thing that we found that scares people a lot is that you still have to write the HTML page for your viewer. Well, in most of the cases, it's just starting from an example and then changing a few parameters, which is pretty much 3/4 of web development now that we have to admit. But still, when you tell people that no, there's not an automatic creator for the viewer, you have to open the HTML and go and change some parameters in the text part of the page, people, especially not from the computer science background, gets a bit scared. And that's another thing that we may want to do. As I said, there's an entire world out there. And I placed here some name, and I kind of ordered them from ready to use, powerful and instant gratification, and on the lowest level, the things that where you can really build whatever application you want from scratch, and you can have much more freedom than using 3D and the final result may be the best 3D platform that you ever encountered, but you have to develop. We could talk hour about all these different things, and I'm not even covering probably 50% of what's out there. So the HTML5 and WebGL really changed the way that 3D is managed online, and you can find many different solutions around. Most of them are extremely good for specific use. So the first advice is to start from one of the simplest that you can find, and then try to find the one that suits you. And the most important thing is probably finding the one that is at the level of automation and configuration that makes you more comfortable to use. So more than the final feature, I would say that it's easier to find the complexity that you can handle it as an individual or as an institution, and start from that one, because it's the limiting factor. It's not the putting out the first viewer, but inserting these libraries, these tools, these software, these services inside your working pipeline, because otherwise all of this is wasted time and takes too many resources if you're not able to integrate it completely in your standard working pipeline. And I'm leaving out full game engine like Unity and Unreal, because they can still be used also on the web, but they are at a completely different level, and probably they are out of the discussion that we are having today. So then there's the limit of growing a tool. So from 2014, 3D has been updated, bug fixed, they're still not pretty standard, and extended without breaking compatibility, which is pretty good. We are happy. But in the end, as the architect of the matrix said, problem just accumulates, and there's a time when you have to scrap everything and start again. And this is the normal part of the circle of the life cycle of a software. And we know that we are also at the moment limited by some of the choices that we did at the beginning, that looked a very nice choice at the beginning, but now they are limiting factor. And since we didn't want to break compatibility, we still need to enforce those choices. But bear in mind that every software needs a time to revamp from scratch. And this is another issue for cultural heritage when you need to work with technology, that the time horizon of digital technologies, and especially web technologies, is way too short for the cultural heritage scholar and museum. So now I'm speaking about 2014 like it was a geological age ago, which for the web it pretty much was. But and it was 6-8 years ago, and for a museum this is nothing. A museum or an institution, cultural heritage institution, they work with a time horizon of 50 years, 100 years in terms of documentation and preserving the data and so on. So another of these things is, yeah, I know that it's complex to embrace this kind of technologies, but it really helps if you're able to separate the data with respect to the technology that you use to display and access. If you're able to separate as much as possible the code that you use to access and show this 3D model and the metadata associated, and how the metadata and data is stored, preserved, and accessed for the future, it's still safe. This, however, will not increase too much the lifespan of your web application, which in any case will need constant update, and we know that this is a hard point in working on cultural heritage. Then, more complaining. Keeping afloat a project like this takes resources and time. And we have a complaint about the open source community in this case, which is the same that happened with Meshlab. So the software is out there on GitHub. We know people are using it. We know there are fixes for some of the bugs. No one ever bothered in sharing their bug fixes or their extension to the software through the GitHub platform or even a private platform. It's a thing that it's not clear. You are able to do it sometimes if it's inside a financed project like national, international, or European project. But it's more difficult to have interconnection at the development level of these technologies. Fortunately, it's possible to find funds and resources and visibility also through this project, but these also limit a bit the kind of development and the direction and the amount of work that you can do. And finally, one other complaint about the situation is that nowadays web technologies are used a lot, especially in private sector. So finding developer with the correct set of skill is becoming difficult, also because in the private sector they get better pay and better opportunity. So this is a problem that we are encountering in finding developer to support some of these projects. Then, perspective. Well, metaverse seems to be the new buzzword, and it will probably remain a buzzword, but still, there will be work in that direction. Metaverse is not just putting things in a virtual reality, because it should be much more, and if it's not able to be that more, which is not part of this talk, I won't enter in detail, but it's not just having a virtual application for a head-mounted display, but it started from there. So we did some experiment with WebVR using our multi-resolution engine, and basically half of the technology that we use for 3D op combined with WebVR. And I will say that what you can achieve is amazing, because streaming high-resolution geometry in VR works very well, and it gives you an incredible sense of scale. So if you're not working on very small object, but you're working on large object or buildings or spaces, it's a thing that you definitely need to pursue. We had problems in the development, and at the moment we have stopped on this track, but we will probably resume it. One thing that you have to understand, however, it's developing a VR application is completely different from developing a 3D application on the web, because the definition of the scene, the kind of interaction you have to define it in a completely different way. So it's not realistic to think about the same library that you use for web presentation of 3D to be directly usable to create virtual reality application, because you need to add much more stuff. But you can probably have something that in between. So you can have a similar management of entities and of concept between the different web application. So you can ease the work of the developer and of the user to obtain a better result. So a more uniform access
that across different interfaces, so web interface or VR interface. But there's a lot to be designed here, because at the moment there's a complete detachment between an interface on 2D screen, especially in the web, and a virtual reality interface. And that is also part of the metaverse problem. So there's not a clear interface and way to interact with this entity, as it is more standardized and clear the rule when you are building a web viewer for your 3D. Then semantics. For a sustainable and interoperable management of digital heritage, it's a very nice sentence, very polite and technical. But what happens is that everyone is moving towards a semantic management of data and metadata. And it's becoming mandatory in the sense that in a few countries now, if you have to, if you work for the state in doing digitalization or diagnostic, you have to provide metadata with a strong semantic mapping. This does not directly affect the viewer itself, but it does affect all the tools that we build over 3DOP. For example, the Neptune Fountain had a very strong semantic mapping that was not standardized in the sense that it was using a semantic mapping defined and used by the Institute for Restoration, the Italian Institute of Restoration, but he had a very strong semantic mapping, and that was very important, was a central part of the project. Is what I showed you more the 3D side, but that part was as important as the 3D management of the data. And we are trying to get on top of the on board on this train, but I would say that I still don't like very much metadata and ontologies. That's another thing of computer scientists that we don't like that kind of stuff, but we work with it. I mean, it's I know all the advantages. I still do. So we have an open collaboration with the INSHA, and we are exploring the integration of 3DOP into OMECA-S, which was already done in the, as I showed you, in the archaeological report. And we believe that this may be a good platform to start with this process. And finally, a word about European Union, because in the end we are working in Europe, and we are often working in European projects. So also the European Union is moving, and there's this code that will come out next year with the idea of supporting a collaborative cloud for cultural heritage. And the idea will follow what data science is already doing. So platform, open platform for the storage and indexing of data, and a very strong semantic management of all the data. And so this is where this connects to the previous slide and to some of the previous projects that I showed you. And then there's the other part that you provide, Europe will provide this platform for storage. And on top of this platform, you will have different tools and services connected to this platform, able to get data from this platform, display, make people work, so create new knowledge, create new data out of it, and then store this new data again, instead is inside this platform. What data science is doing, basically. And so you see that the scheme that we were working, so the idea that we started with just showing 3D models, then measuring and do technical work on it, and then closing the circle in using the web application to create new data, and then feeding it inside the viewer itself to make things more complex. Everything connects. So we believe that this goal and this collaborative cloud for cultural heritage could be a good opportunity for all the people that are interested in this technology, and a lot of opportunity, especially because as from the report, from the preliminary report, and what we know about this code, it seems clear that they will be open to have multiple services. So everyone that wants to build an application to display, create data, and measure in a technical way data will have space to interconnect, and the web technology are clearly at a good point to do so. And I would say that France started with an advantage because it has worked for years to build a tool and platform for the use of researchers and scholars. So it's a thing that this basic idea was not something that we only us worked on, but many laboratories and institutions already are working in this direction, and it seems that we are going towards convergence between all the different technologies. So I thank you for your attention. I'm more or less in time, and I'm available for question, curiosity, and whatever you want to.
Thank you very much, Marco. You are perfect in time. 1 hour presentation. It was a really interesting presentation. I well knew 3D Haute, but to hear from you about all the project and all the perspective and development, the further development is yet good. I just a reminder for those who follow the presentation online on Zoom, you can ask to Marco your questions by clicking on Q&A or Q&A for the English speaker, and or by raising your hand. So if you want to ask some question, I have to admit I can't be happy to hear that you still hate metadata and ontologies, despite my efforts to bring you love the metadata. But I well understand the meaning.
Filling in fields when I need to enter data. Yeah, it's a thing that it's like documentation. We just we don't like it, but it's for personal reason. It's not. I clearly see how the strong semantic mapping helps a lot. Helps also the development side because it makes things clearer and it allows you to just dig inside random stuff when you receive data from someone else, which is the thing that we often did. So it happened many times that doing a project, someone came, oh, but someone already did a database on it. I still have the table somewhere, and they give you this long table, and the field, the name of the field tells you nothing, and you have to just like understanding the hieroglyphs the first time. You have to guess work until you find what was the meaning of the data. And we see that this trend is going strong at local and European level. And I would say I'm happy, and if I'm able to find a good software to manage this for me, so the part of the semantic web, which is not part of my background, I would be glad to use it. It was more a joke than, but it's a joke, but I'm pretty serious when I say it.
Okay. So I'll go back to the core of your of 3D Haute, and you list a lot of things you think maybe you did wrong concerning the users and the fact that the user don't use in an advanced way 3D Haute. I consider myself as an advanced user because I love the API and the documentation you wrote about I would like to stress the fact that 3D Open is a well-documented API online that could be used for develop further web portals. But there is a point for me concerning the file formats, because so far the user can use PLY or Nexus files. And my question is, do you plan to integrate further formats in this kind of rebuilding of
yes.
video?
Yes. However, the thing about the multi-resolution format is the fact that with multi-resolution you can use very high resolution geometry, but anything above a couple of megabytes, ideally, I will not even talk about the number of triangles. We say if the file, the 3D model that you want to display online is more than a couple of megabytes, it will pay off if you convert it to the multi-resolution. So I know that there was a complaint by many people, oh, I already have my model in OBJ format or STL or whatever other format. And they wanted to put it online as it is. And it's partly because the problem in 3D is that, yeah, we don't support that format directly, that format. But the other is you should not put that model as it is on web. And if you look closely, in most of the other tools, even if even when they have more automatic processing, they will still convert your original format into a stream-friendly web format. It's just that you don't see it. Some of the existing services, like Sketchfab, for example, you can load your data in different formats, but in the end, what you see in the viewer is a different format that is being created to be efficiently transmitted online. And it's the same on other viewer. When you work with Pottery, it will process your data to make it easier to stream. So it will change how the points are arranged to be stream friendly. I believe that in that case there was a more communication problem with and we plan to integrate other formats, but we know that people will try to put online a 1 gigabyte file and then say, why when I loaded the page nothing shows up? And yeah, so that one.
So far, the best way is to manage files through software like MeshLab and then export on multiscalar.
I would say that is the best strategy, because even if, and I also said it in the presentation, you want to use the same data for the technical study and for the visualization online for the general public. But this does not mean that you don't have to work a bit on the 3D model for visualization. There are some, the scientific management of data is complex. So you want to be sure that every time you touch your data, you are not, especially if you measure it with care and you are using it for scientific purposes, you cannot go there and feel whole, smooth the 3D model and think that you are still having scientific data. But for many applications, you need some work. You want to print your 3D model, you have to close holes, even if you're inventing stuff. You want to render it in Blender, in Maya, in whatever, you probably need to smooth it out and reduce the face number and close the hole. So depending on your application, you will need to process a bit your 3D model. And when you publish it online, it helps if you consider that publishing is an output thing. So even if you change it a bit, maybe the orientation, maybe the format, and especially to make it more suitable for presentation, you are not violating the scientific validity of your data. That part is just for the visualization, sake of visualization.
Okay, thank you very much for your answer. Waiting for some, there is a question. So it's from Loïc Janson, the University of Lausanne and the INHR also. Thank you very much for this wonderful presentation. Could you give more details on the annotation of 3D models? How are generated the 3D areas, or more generally, the geometries supporting annotations in the model?
Okay, that's a good question, and that's an open problem because, well, it's an open problem at two different levels. I will firstly say the easier one. There is no standard for annotation on a 3D model. And that's another open problem that is a recurring one, because you see that here we annotate the 3D model, but also here what we want to do is, in many cases, create data and annotation on the 3D model. And also here I am annotating the 3D model by areas, by points, by lines. So there is not a standard way to save it. Also in terms of file, how you save it in terms of file format, and how to save it in terms of semantics. That's also a missing thing. So we took a look at some project, at some standard like the TEI encoding for text as a standard for 2D image annotation, but not 3D data annotation. So that's an open problem. And then the technical problem of doing this online is that it's difficult to create these areas, because especially when you work on a web visualization and a multi-resolution visualization, you don't have your 3D model in memory. So what happens is that you have your 3D model because you can see it. I mean, we're not cheating, so you have something there, but something that is constantly changing. So you don't have one single geometry, but you have a local representation of the geometry. That's because of the streaming. And this is quite common across all the platforms. So when you are annotating the object, you have to take care that the annotation is not something that is exactly on the surface, but something that can be mapped on the various level of resolution, level of detail of the object. Depending on the project, we did it in different ways. So points and points with area are easy because you just pick the point, which is possible in most of the multi-resolution engine, not just the Nexus one, but also on the other, the X3D multi-resolution and other. You can get the exact point where you pick with the mouse. So lines, polylines, points, and points with area are easy. Areas are a bit more complex. In the case of the Neptune, all the details are in the relative publication. I can send maybe later the link to the publication. What we actually do is we compute a bounding box of an extruded box of the polyline, and we use that as a way to transfer that annotation on all the different levels of detail. So what you see here displayed as an area is in fact a rendering trick. So we have a precise outline on the high resolution geometry, but in order to render without the classic thing where you see the Z fighting, so you see the annotation going above and below the surface, we use a specific trick rendering that use a volume around the annotation, and these also take care of transferring the annotation across the different resolution. However, there are various ways of picking point in a way that is safe for multi-resolution geometries, and also for web application where the final precision of the 3D rendering is not as good as on a dedicated application. This is another of the hidden flaws of web on 3D, on web 3D, that the final rendering may be slightly inexact because the standard says that if the computer is taking too long, it can reduce the precision of some calculation. So you have to you have to create software routines that are safe with respect to precision and respect to this multi-resolution geometry. But yes, it's an open issue, and has been solved in different way. If you've seen there was a previous presentation of the Lundis Numerique presenting IOLI. They work in this hybrid 2D, 3D projected space. So they try to avoid this precision problem by every time projecting the annotation back on the viewing image and then projecting it back on the local geometry that you have. And this is also another solution. But also that solution is not standardized in terms of format and in terms of mapping metadata. Other have worked with the volume, so they create a volumetric grid around the object, and other they use a refinement scheme, so they sketch a very rough outline and then they refine it and adapt to the local software, refine and adapt, refine and adapt. So they have a cycle to create a better mapping. And there's a problem also on the amount of data you produce, because in the end we discovered that when they said to us, well, we want to annotate the object, we had this idea of, they will make a couple of areas for a thematic map. A thematic map, that means let's map all the black spot or all the oxidation on the bronze, is made of hundreds of these areas, and are super small, and they're made of hundreds of points. So at one point, for some of the map, there was more data on the mapping than on the actual 3D model, because we have multiple layers. So also maintaining this data and streaming back that data require a lot of time. So we've got the data, we stream it to the server stored it, try to optimize it in order to make it smaller when you have to stream it back, because everything should be kept in a state where you could edit it back. Because this geometry, you cannot change the geometry in multi-resolution structure, so you cannot modify it. But we wanted to be able to modify the annotation, so you have to take care of that part too.
In my opinion, if I can add something, I think it's typically the thing that the IIIF consortium should answer on this, but as they did with the manifest, the JSON manifest for images. But I think there's not an evolution on IIIF 3D. I don't know if you. I think then we have another question from Loic. Then. If you want, I just read the question from Loic, and maybe to follow up Federico's question on the file format. Working in teams sometimes means that people use different tools to work, and it's sometimes needed to visualize intermediate steps and then go back to other software to keep on working before visualizing the new results again. How would you say 3DOP has been integrated in workflows, and has 3DOP already been used in association with GIS software?
Okay, I know that is perfectly right. It's an issue, and at the moment I will say that we were able to use 3DOP in a loop, but inside a dedicated web app, like the Neptune or the other one that I showed. But we considered when you go towards the visualization, is difficult to get back into the working on the 3D model. And yeah, that's complex also, because also for things that seems very stupid. So in some of these viewer, we have the concept of predefined view. So we have a camera that points a certain location. That thing is again non-standard across all the software. So I have a point of view inside 3DOP, but if I need to bring it back inside MeshLab or inside Blender, I am unable to do so. And I know that is I've tried to save some of this view in such a way that can be with a script then converted, because I save it in a format which is very similar to the original OpenGL camera. So location of the camera, orientation, and focal length. So with those data, it's possible to create a Blender camera or a Maya camera or a MeshLab orientation. But yes, that's another thing that we have not worked much on, and I would say it's a common problem in this. So some software are not a dead end, but it's easy to bring data there, but bringing back information may be tricky. And it's again recurring the same problem of the annotation that we were discussing before. The annotation that we do inside the software can be exported as line, polyline, yes, but you need to find the correct format that your other tool uses. But I would say that it's also a problem that already exists in before going on the web platform. So we use, as all the people working on 3D use a lot of software all at the same time. Cloud Compare, MeshLab, MeshMixer, Blender, SketchUp. I use all of them all together. And I have all my own recipe when I need to go from software A to software B, because one is right hand, the other is left hand, another is Y vertical, another is Z vertical. One form when I go to Blender, color is good when I use PLY, but text is better if I use OBJ. And so the problem predates going towards the web, but you are perfectly right. The web has probably increased this problem because most of these tools, and 3DOP is not an exception, are made as endpoint. It's difficult to get data back. Like PO3 is very good because PO3, the annotation that you do in PO3, you can export in the XF or other JSON format. And we may think to do the same in this case, but it will shift a bit the equilibrium, but not provide a complete solution. And for GIS we have a problem that is, again, pretty common with web, is the fact that geographical coordinates are difficult to manage on web application because the kind of number they use and the limited precision that you have inside the web, inside the browser, the JavaScript level. One solution is to, your software has to do a switch of reference space, so going from a local global reference space, which is used by most of the GIS tool, you switch it to a local reference system, you work locally, and then you transfer back all your annotation and measurement and so on, which is a thing that behind the scene is done by all the software that manage the data. So if you use Cloud Compare and you load a 3D model that is being saved in absolute coordinates, you have a pop-up, they say, oh, this model is in absolute coordinate, I will not be able to work on it, I will shift it towards origin, I will let you work on the origin, and on export, I will reset again the space. So we have to include these. The moment 3DOP is not really supported that kind of coordinate, so it's better if you do the shift before publishing, and then in the web application, when I give all the measurement, all the volumes, and all the positioning, I can add what I normally do is add the shift to all the output that we produce.
Thank you, Marco. Again, we have another question, and concerning the development, etc. So having 3D Hope used in so many projects, what new ideas or unsuspected needs have the various projects brought to the development, or what would be the biggest and most interesting challenge brought up by projects?
The most interesting challenge is this one about the annotation, which is well, annotation is a pretty generic term, and in fact, I showed you a lot of different stuff, and in the end, they boil down to annotating the geometry. So that is that's an interesting thing to work on. As I said, on the technology level, to make it efficient on the web, and on the semantic level to provide a mapping that makes sense and is somehow standardized. And I would say that we try to integrate a lot of the things that we learned with the project in terms of interface and tool that we added, and in things that we needed to in specific projects. So like the working on the dynamic collection, and then on the Notre Dame restoration, we had the need to make the object more understandable in terms of size, so building this reference grid and being more explicit in how you are navigating the object using gizmo that show you a recap of the view. The original way that we had to change the light did not give you any feedback on the position, so we developed a different input that is easier to use and give you a better feedback on the direction of lighting. We have added many of these things as soon as they became relevant in some of the project. I would say that we found many small components working in the project, and it was very helpful, the input of the user in finding a better solution for the interface, which, by the way, is by no means perfect or finished. I know that the interaction is the hardest point, especially in the beginning, for people from a different background interacting with the 3D model. It's complex. Another thing that is missing is navigation that is more like a first-person navigation, and it's not a major problem in itself, but it will require a lot of input when you create the scene, and this also, it's another of those directions that makes things difficult to create a viewer that lets you go inside the object, because you don't just need to provide a 3D model, but you need to provide collision meshes and limits and much more configuration. And since we already see people struggling with configuring some of the complex elements, it's probably something that we will skip for a bit.
So, Loic said, thank you so much for the very complete and informative answers, and again for the wonderful presentation. Thank you, Loic, for your questions. We have another question from someone involved in specific projects from Paula De Rudas from the Lund University. The question is, do you foresee the possibility to develop a scaffolding structure to aid the user to use the 3D Open in a more advanced way?
Well, the authoring of a viewer, it's always a difficult thing, because you want either to provide a visual way to add the configuration and not having the person write code. We did something similar in a project. Now I'm going after. So we have built for the Ariadne project a service that helps simplifying the creation let's see if it works. So this is a system where you can upload your 3D model, and we have built a configuration wizard for your 3D model. So the possibility of loading the model, putting it straight, control which tool you want to include some of the gizmo and predefined components for exploring and taking a look at and interact with your 3D model. However, it's more complex to make it it's there and it provides some basic functionality. Ideally, we want to add more configuration option and try to make it a more stable product, even though we are not sure on how to make it available. So it should be part of the standard installation. It should work as a service, like in this case. So you have a website that help you create your viewer and then let you download everything, which, by the way, this project has been developed for the Ariadne and then Ariadne Plus European project. So I work with the idea of providing a service for cultural heritage operator. So what you can do is load your 3D model, and you may decide to list it online, or you keep it private, and you can use it just to build the viewer, and then you can download everything and remove it from the server. So it works also in this way as a support for automated authoring. Ideally, some basic authoring, some basic wizard authoring should be part of a new version of 3DOP, but we're still trying to design at which level to put it and how to integrate in the standard distribution. Because there are other software, like other solutions, like for example, Babylon.js has a pretty good integrated authoring tool. So I would say that it's easy to build complex scene there, because you visually can place objects, move around, but it takes a lot of time to build that authoring tool. While Sketchfab has also a pretty good configuration for your viewer, even though the amount of added components and tools are limited, because Sketchfab tries to be as streamlined as possible in terms of access to the viewer. So it's a very simple viewer to be as simple to use as possible, and it pays off because they are basically the YouTube of 3D model, because of that approach, which is limited in terms of functionality, but much more accessible from the authoring point of view and from the user point of view.
Thank you very much, Marco. We have to end this session because the time is running out. And I just switched French to the end of this session. Et donc, merci vraiment à tout le monde d'avoir participé à cette présentation, à cette séance de lundi numérique. La prochaine séance, voilà, je vous rappelle que la prochaine séance du séminaire aura lieu le 9 janvier 2023. Aura pour titre « Numériser et publier des objets quotidiens, les dessins et modèles des archives de Paris ». Donc, merci à tout le monde et à bientôt.